This video is about taking out a greatest common factor. We normally shorten it to GCF. And a greatest common factor is the biggest number that you can divide everything in the equation by. So when we're thinking about greatest common factors, we're thinking about multiplying and dividing in our head. We're not thinking about adding and subtracting. It also could be, your greatest common factor could be numbers, it could be letters, and it could be both. We will see some examples of that. If I have 2x plus 4, I'm not going to combine the 2x and the plus 4. I can't combine them. But what I can do is I can notice that this part has a 2 and this part has a 4. Both of those numbers can be divided by 2 and I get whole numbers. I don't get decimal numbers. So if I divide by 2, that means that is my greatest common factor. Like that's the biggest number I can divide both of them by. So my greatest common factor is 2. I bring that out and I put it in the front. And then I put parentheses. If I did 2 divided by 2, I would have a number 1 left over. And I would also have a letter X. So I could put a 1x, but I know that in front of that x there is an imaginary number 1, and so I'm not going to write it. Then if I do 4 divided by 2, I get positive 2. So I took out my greatest common factor of 2, and then I showed what was left over in parentheses. If you want to double check your answer, you could always multiply. 2 times x gives me 2x. 2 times 2 gives me plus 4. And so this right here is where we took out the greatest common factor of 2x plus 4. In this next one, we have a 6x plus 12. So when I look at these numbers, I could divide them both by 2. 6 divided by 2 and 12 divided by 2. But I think there's another number I can divide by, right? I can also divide by 3. 6 divided by 3, 12 divided by 3, those both give me whole numbers. And I think there's an even bigger number. So that's why it's called the greatest common factor. I want to take out the biggest possible number I can. So between a 6 and a 12, the biggest possible number I can divide them by is 6. So my greatest common factor is 6. If you did it with a 2 or a 3, then you would still have to factor out more, and you would end up getting to a 6 anyways. So you want to try to take out the biggest number right from the beginning. 6 divided by 6 makes 1, and the x is still left. So I'm going to leave it as an x. Again, you could put a number 1 in the front, but I'm just going to put mine as x. 12 divided by 6 is positive 2. So when I took out my greatest common factor of 6, I had an x plus 2 left. 6 times x is 6x. 6 times 2 is 12. I've got a couple other examples here. In this one, it looks like the biggest number I'm seeing in common is a 3. So my greatest common factor is a 3. 3 divided by 3 is 1. So I have an x left over. And then 18 divided by 3 is 6. Okay, and then I'm actually noticing that I did something that I didn't want to do, so I'm going to change this next problem. So this is my answer, right? I did a 3 times x is 3x, 3 times 6 is 18. So I'm going to change this problem. I'm going to make it a 15x squared minus 10x, just to show you something a little different. So this one has a couple different things. One is when I'm looking at the numbers, I still find a number that they have in common, and I think the biggest number I can find that they have in common is 5. Some people would want to say 10 because they think of 15, but if I did 15 divided by 10, I'm going to get a decimal. So I think the biggest number they have in common is a 5. I also noticed that they both have an x. In all the other problems, only one part had an x, but in this one, they both have an x. So I'm going to factor out a 5. I'm also going to factor out an x because they both have it. 15 divided by 5 is 3, right? The x doesn't always have to just be a plain x. It sometimes has numbers left over in the beginning. And then if I had an x squared and I divided it by an x, that means it would go from squared and now it would just be regular x. Then if I had negative 10 divided by 5, I have negative 2 or minus 2. And if I had an x divided by an x, it would cancel and make a number 1. And so if I had 5x as my greatest common factor, I would have a 3x minus 2 left. 5x times 3x makes 15x squared. 5x times negative 2 makes negative 10x. We've got some more factoring, and then we do have some factoring using rectangles. This time I made it so it has 3 parts, and you have to find what factor they all have in common. So when I'm looking at the 4 and the 8, it kind of looks like I could factor out a number 4, because that's the biggest number they have in common. But then when I go to the 6, 6 can't be divided by 4 and give me a whole number. So I have to find something that they all have in common, and I think what they all have in common is a number 2. Again, if I look at the 4x squared and the 8x, it looks like they have an x in common, but then when I look at the 6, it doesn't have an x, and so I can't factor out an x. So my greatest common factor in this case is a 2. 4 divided by 2 is 2, and then I didn't factor out any x's, so I still have an x squared. Negative 8 divided by 2 is negative 4. And then I still have an x because I didn't factor it out. 6 divided by 2 is 3. So that right there is taking out the GCF. And now, making it a little more complicated, we have some problems where we have to do more than one GCF. We actually have to do 4 GCFs in these problems. Every single time I have to look at every row. So for example, I'm looking at these 2 numbers and I'm finding out what their GCF is, and then once I see what it is, I can put it in front of that row. So an x squared and a 3x have a letter x in common. They don't have a number because this one has a 1 and this one has a 3, but they do have a letter x in common. Then I can look at another row, like this bottom row. If I have a 2x and a 6, I think they have a number 2 in common. They don't have a letter x in common. Then I have to do the columns. So I have to look at this column right here. These ones, they don't have a number in common because again, this is a 1, but they do have a letter x in common. And then I also have to look at my last column. A 3x and a 6 have a number 3 in common. So I looked at every single row and every single column to see what they had in common. And then once I write my answer, I would say I have an x with a positive 2 and I have an x with a positive 3. So factoring out the GCFs, and then I could write my answer as a product. Right? This times this gave me all the stuff on the inside. So see if you can do a couple more GCFs. I'll walk you through the process, but then you'll have some practice to do on your own. So if I look at this row, think about what the GCF is. I think they have a 2 and an x in common on that row. On this row, they don't have an x in common, but I think they have a number 3 in common. On this column, I think they only have an x in common. I don't think they have a number. And then on this one, a 14 and a 21 have a number 7 in common. And so when I write my answer as a product, I have an x with a positive 7, and I have a 2x with a positive 3. But all this part was taking out my GCF. So there's 1, 2, 3, 4 different GCFs in this problem. See if you could pause the video and do this last one by yourself. In the top row, I'm seeing a letter x in common. In the bottom row, I'm seeing a number 2. In the first column, I'm seeing a 4 and an x. So if you thought of the number 2, you're right that there's a bigger number. There's a number 4 and a letter x. And then in this column, they both have a negative sign. So we have to bring the negative. And then I'm not seeing a letter or a number that they have in common. I can't put 0 though, because if I do 2 times 0, it's going to make 0. So if I'm saying that they don't have a number in common, remember any number can be divided by 1. So I think they actually do have a number 1 in common. And then checking my answer, like 4x times x makes 4x squared. Negative 1 times x makes negative 1x or negative x. 4x times 2 makes 8x, and negative 1 times 2 makes negative 2. So my answer as a product is an x with a positive 2 and a 4x with a minus 1.